So you guys know from geometry, but I'll remind you that triangles are going to be congruent if they follow some of these basic rules. So, for example, if you have three sides of triangle, like let's say you have a 3, 4, 6 triangle, then there's only that triangle that can be made with those three side lengths. Like I can't move these side lengths around. Like I could do like, okay, this one's 3, this one's 4, and this one's 6, but they're still equivalent triangles because the side lengths are the same. Likewise, if you have like two angles and a given side. So like if I have, I know this angle is 20 degrees, this angle is 50 degrees, and then I have this side is 10. I cannot create another triangle that's a totally different size with angle measures 20, 50, and then a side length of 10. So if you have like side, 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 or angle, angle, side, or angle, side, angle, it doesn't matter what you call it, as long as you have two angles and a side. Or if you have side, angle, side, and that's when you have like, okay, this side length is 3, the angle between them is 70, and then this side length is 5. There's only one way for me to finish this triangle with one side length of whatever it is. So these are your triangle congruence theorems from geometry, where you can only create one triangle, one possible triangle given this information. Now, the ambiguous case of law of sines is what happens if you have the side-side angle case. Okay, so you'll notice that side-side angle is not something that we cover in the triangle congruence because side-side angle does not guarantee that you have one triangle with those measurements. In fact, you could have no triangles, you could have one triangle, or you could have two triangles with those measurements. So we are going to go through the different cases where this can happen. So okay, I've kind of said this weird. I said two triangle non-congruence cases. And what I mean by that is when you have an obtuse angle. And in that case, what I've listed here, that's going to be case numbers 1 and 2. And then you can also have an acute angle. And that's case number 3 and, oh wait. Okay, I shouldn't call these cases. You can have an obtuse, sorry, I just realized I called also these cases 1, 2, 3, and 4. But basically you can have obtuse or you can have acute. Okay, I'll just kind of separate it like that. You can have an obtuse ambiguous case of law of sines, or you can have an acute ambiguous case law of sines. So let's go through each of these cases, and then you'll have a better idea of what I'm talking about when I say like non-congruence. So let's say you have a side-side angle. So what that means is, and I always want you to draw it like this. You have an angle you have an angle down here. It's greater than 90 degrees. Okay. So let's say it's 110 degrees. And then for side-side angle, it's not that I know this side and this side, because that would be side angle side. So side-side angle would be like, okay, I know this side is 9 and I know this side is 6. Okay, now you'll notice I kind of drew this weird. It actually doesn't create a triangle, because if you have a 9 and it's not across from the largest angle, that's not possible. Your largest angle, and you know this is going to be the largest angle because angles in a triangle have to add up to be 180. So 110 has to be the largest angle. Well, if 110 is the largest angle and 6 is across from it, there are no possible triangles where this can be the case. Okay, so there's no triangles where you can have a side length of 6 across from 110 degrees and then have a different side length greater than 6. And then in this next case, I don't know what happened here. That's supposed to be a 6. So let's say I have 110 degrees. The angle across from it, the side length across from it is 9. And then this side length is 6. So this is a side angle case. Now this is not a contradiction, because you can have a side length of 9 across from 110 degrees with another side length of 6. So in this case, the first case, it is a contradiction, so it's not possible. In this case, there's one triangle I can make. Okay, so you can kind of already see what I mean by side-side angle. Like, there's a lot of different possibilities that you can have. So if you have an obtuse angle in side-side angle, it might be no triangles or one triangle. Okay, well, what happens if you have an acute angle? So let's say you have 30 degrees here, A is 3, and B is 6. So the question is, how many triangles can I come up with where this is the case? So what I want you to do for all of these cases is I want you to find the height first, because that's going to help me figure out if I'm going to have no cases or one case or possibly two triangles. So in this case, I have a height, which I can solve for. Okay, so I'm going to look at like kind of this triangle here. If I create a 90-degree angle, and then this is 30 degrees, and then the hypotenuse is 6. So sine in SOHCAHTOA, sine is equal to opposite over hypotenuse. Okay, sine of 30 is equal to opposite over hypotenuse. So that's going to be h, because h is the opposite side of 30. And then 6 is the hypotenuse of that blue triangle. So I get 6 times sine of 30 is equal to h. Okay, well, I actually know what sine of 30 is because I know my unit circle, right? So sine of 30 is a half. So h is equal to 3. Okay, so I'm going to amend my picture here, because if I have a height of 3, can this side also be 3? No, because they can't be the same size. So this is going to be one triangle. The only triangle I can create is where the height is equal to that A value. Okay, so if your height is equal to the length across, the side length across from the given angle, then you only have one triangle. It's a right triangle. So given angle A, if side length A and a side angle is equal to the height, then there's only one triangle. Okay. Now let's try this. We've got A is 30 degrees, so I've still got 30 degrees here. I've still got 6 here, because again, B is going to be adjacent to angle A. But the side length across is 2. Okay, well, if the height is 3 and the side length across is 2, can I create any triangles? No, because the side length across can't be shorter than the height. If the side length across is shorter than the height, this just isn't possible. So if A is less than the height, there are no triangles possible. There's no possible way for me to have a side length that's shorter than the height, given this information. So if you solve for the height and your A length is smaller, then you can't create any triangles. Okay, what if we have 30 degrees? Okay, B is 6 and A is 8. Okay, that I can create. So I, again, the height is only 3. So then 8 kind of creates this side length over here. And then this is possible. So this is just one possible triangle. And that's when your A is greater than your B. Okay, so looking at my values, I've got A is greater than B. And then lastly, what if we have 30 degrees here? We've got B is 6, and we've got A is 5. So 5 is still bigger than the height, which is great. But in this case, A is greater than the height, but it's less than the B value. So what if that's the case? This case, there's actually 2 triangles. Well, how do I create a second triangle given this information? So I still have a 30-degree angle. Okay, I have to be careful about how I draw this because it's kind of hard. Okay, I still have a 30-degree angle. I still have a side length of 6. But instead of 5 going this way, what if my 5 goes this way? So basically what I've done is I've kind of taken this side and I've swiveled it over here to create this obtuse triangle. So this is the case where there are 2 triangles. You can create kind of this bigger acute triangle, and that one's kind of the easier one to solve for. And then we also have like this weird small obtuse, I don't know why I called it weird, but it's a smaller obtuse triangle. Okay, so how do I actually solve? So the first thing I'm going to do is solve for, I'll do it in purple. I'm going to solve this triangle right here. Okay, so this is what I'm going to do. I'm going to say, okay, sine of 30 over 5 is equal to sine of b over 6. So I'm going to use law of sines and I'm going to start solving. So sine of 30 is a half divided by 5. So I get, you could just use a calculator. I'm fine with that too. Sine of b over 6. Cross multiply, I get 6 over 10 is equal to sine of b. Do sine inverse of both sides. And I get b is equal to, hold on, let me use my calculator here. Okay, 6 over 10. Okay, and I get b is 36 point, let's call it 87 degrees. Okay, and then what I would do, and I'm actually going to call that b sub 1, because remember I have 2 different triangles I can make. So I'm going to call that b sub 1. And then, okay, now I have 2 angles, so I can solve for the third angle. So it's going to be 180 minus 30 minus b sub 1. So that's going to be, I did something wrong here. 150 minus 36.87 is equal to 113.13 degrees. So that's my c sub 1. Okay. And then to solve for that last side length of c, I'll call it lowercase c sub 1. I'm not going to do this one for you, but you would do sine of c sub 1 over lowercase c sub 1. So I just plug that in here, is equal to sine of 30 over 5. I would cross multiply and solve, and you can do that part yourself because you guys can do algebra. But the only thing is, don't actually plug in this number. Like, leave it in your calculator. Leave the exact number, not 113.13, but like the many, many decimal places that come after it. Leave that in your calculator, take the sign of it, and then divide it by, like, actually solve this with the real number plugged in, not just round it to 2 decimal places. Okay, so what about that second triangle here, this obtuse triangle? So I'm going to call this b sub 2. I'll call this one c sub 2, and I'll call this side length c sub 2. So it works like this. If you were to, again, I'm going to kind of like draw it like large, okay? So I have my 6 here, I've got my 5 here, I've got my 30 degrees here. That's my first triangle I can create. If I were to like swivel, so I take this side length and I swivel it, I still have a side length of 5. I didn't do a very good job, but I still have a side length of 5 here. But now I have this smaller triangle that also is 30 degrees with a side length of 5 and a side length of 6. So how do I solve this smaller one? When I swivel it, it creates 2 congruent angles. So b sub 2 is here, right? That's this angle. That's also here. So then to solve for this angle, that angle, call it, I'm sorry, this was b sub 1. I've lost my mind. Too many b's. B sub 1. B sub 2 is equal to 180 minus b sub 1. So when I solve this second triangle here, b sub 2 is going to be equal to 180 minus whatever b sub 1 was. So that's 180 minus 36 point whatever, and that's 143.13. And again, that is rounded. So in my calculator, I've kept like many other decimal places. But that's going to be my B sub 2. C sub 2 will be 180 minus 30 minus B sub 2, and it's going to be a really small number. So I end up with, let's see, 30 minus, 150 minus 143.13. Yep, it's a really small number, 6.87 degrees. So remember, that's this angle right here is that C sub 2. You can see I knew it was going to be a small angle because I can tell from my picture it's going to be a small angle, but it is a very small angle. Okay, so C sub 2 is equal to 180 minus A minus B sub 2. So that's my C sub 2. And then again, to solve for lowercase c, you're going to do sine of C sub 2, again, leaving this in your calculator, over lowercase c sub 2 is equal to sine of B sub 2. I'm sorry, let's do sine of 30 over 5. And then again, it's two triangles with the same information. They both have an angle of 30. They both have a side length of 5 across from an angle of 30. And they both have a different side of 6. And it creates these two different triangles because of this relationship. So I know it seems overwhelming because there's a lot of different cases. So let me run through it one more time in case you need it, although you should really just rewatch the video if there was any part that confused you. If you have side-side angle, there are many possible cases. If you have an obtuse angle, just make sure there's no contradiction. Okay, so here we had a contradiction because your smallest side length can't be across from the largest angle measure. That's a contradiction. Here, this was one triangle was possible. We did not have a contradiction here. So here, I would have just set this up as, okay, sine of 110 over 9 is equal to sine of b over 6. And then I would have just used sine inverse, and I would have been fine. And I would just solve it, okay? But then when I have an acute angle, I have a bunch of different cases. So in all of these cases, what did I find first? The height. You need to solve for the height and then figure out what happens. If the angle and the side length across from it, okay, create a 90-degree angle because the side length across from the given angle is equal to the height, then that's a right angle. So there's only one possible triangle. There's only one possible right triangle you can create there. If your given side across from the given angle is too short, so it's shorter than the height, okay, it's too short, then there's no possible triangles. Sorry about that noise. My cat is going insane. Okay. If you have where your side length across from the given angle is longer than the other side length, there's only one possible triangle. So if you think about like the swiveling I did on the last case, like there's no way for me to swivel that 8. If I were to try to do that, like if I have a 6 here, if I swivel the 8 like over here, then it like is a contradiction because my 30 degrees is right here. I can't change where that 30 degrees occurs. So, there's no way for me to create any more triangles with the given information if my side length across from the given angle is the longest side length. Okay, and then the case where it did come up with two answers was when that A value, so the one that was across from the given angle, is between the other side length and the height. Then I'm able to create like kind of this larger acute triangle and then a smaller obtuse triangle by swiveling this side around to right here, okay? And then that creates kind of like this small little wedge. So I know it's a lot, but just make sure you find the height first, because you're comparing all of these A values to the height first, and then you can compare to the B if it's not one of these first two cases where A is equal to the height or A is less than the height. Those are kind of like the easiest cases. If your A is greater than the height, then you want to compare it to the B value to see if you have one or two triangles. And if you have two triangles, that means you have to go through and solve the first triangle And you have to use this relationship here to solve for that second smaller obtuse triangle. And I think that's it for the ambiguous case. Again, once you figure out how many triangles there are, you're just using law of sines. You're just using that formula, cross multiply, solve. You should be in degrees mode, and I think that's pretty much it for these types of problems.